Let's look at some simple examples of evaluating limits using graphs. Evaluate each of the following limits using the given graphs. The limit as x approaches 4 of f of x, the limit as x approaches 4 of g of x, and the limit as x approaches 4 of h of x. All three of these limits are as x approaches 4, and the graphs of f, g, and h are very similar, but each a little different. Our intuitive idea of a limit says that to evaluate the limit of each function as x approaches 4, we need to see what the function is approaching as x gets closer and closer to 4. The values of the functions are given by the y-coordinates. So we need to look to see what is happening to the y-coordinates on the graph as the x-coordinates approach 4. For the first graph, the graph of f, it is as simple as looking at the point 4, 5, and seeing that as we approach the point from either side, the y values do appear to be approaching 5. Compare this to the graph of g. The point on the function with x-coordinate 4 is actually 4, 2. But if we look at the points near x equals 4, the y-coordinates aren't approaching 2 at all. The y-coordinates are still approaching 5 as x approaches 5. And remember, when dealing with limits, it doesn't matter what happens at the value, only what happens as we approach the value. Finally, for the graph of h, there isn't even a point at x equals 4. The function is undefined at x equals 4, but it still doesn't affect the limit. All that matters is that as we approach x equals 4, the function looks like it's headed for y equals 5. So in all three cases, the limit as x approaches 4 is 5. Let's look at one more example before we give a more formal definition of a limit. Evaluate the limit as x approaches 2 of g of x using the graph below. There is something very different about this graph compared to the others. As we approach x equals 2, what happens to y? Well, that depends. Which direction are we approaching from? If we approach from the left, the graph heads towards y equals 3. But if we approach from the right, the graph heads towards y equals 1. How do we choose? The answer is we can't. There's no reason to favor one side over the other. When this happens, we say that the limit does not exist. The abbreviation DNE is commonly used for does not exist. Because of functions like this, we need to refine our definition of a limit. A still somewhat imprecise definition of a limit says that the limit of a function g as x approaches a exists and is equal to L if, as x gets closer to a, but not equal to a, from both sides, g of x gets arbitrarily close to L. Note that this is still not precise enough for math. If you plan to major or minor in mathematics, I recommend that you check out the precise definition of a limit. With this new understanding of what a limit is, if the function approaches two different values from the two different sides as x approaches a, then there is no limit as x approaches a. Instead, we can define what are called one-sided limits. The notation, the limit as x approaches a of g of x with a little superscript plus on the a, means the limit as x approaches a from the right. In other words, we are only considering x values that are strictly larger than a. You can think of the plus as meaning we're approaching from the positive side of the x-axis. Similarly, the notation, the limit as x approaches a of g of x with a superscript minus sign means the limit as x approaches a from the left, meaning we are only considering x values that are strictly less than a. You can think of the minus as meaning approaching from the negative side of the x-axis. Going back to the previous example, while the limit as x approaches 2 of g of x does not exist, the one-sided limits as x approaches 2 from the right and from the left do exist. When we only consider x values larger than 2, the function approaches 1 as x approaches 2. So the limit as x approaches 2 from the right of g of x is equal to 1. When we only consider x values less than 2, the function approaches 3. So the limit as x approaches 2 from the left of g of x is 3. So the main point to remember about one-sided limits is that the limit as x approaches a from both sides of f of x only exists if both of the one-sided limits exist and are equal.